Welcome back. In this video, we are going to talk about an important concept called position vector, and we'll introduce you to section formula. So let's talk more about position vector. So let's think about a dimension. So x, y, and z. And if you have any point A with A1, A2, A3 with respect to a certain origin O, right? So we can say OA or point A is a position vector represented by A1 I hat plus A2 J hat plus A3 J hat, right? So position vector is basically the point in the space with respect to certain origin O and can be represented by a vector OA. So what is so different about position vector, as what we have been dealing this in almost all our concepts from the beginning, right? So remember, a position vector is with respect to a certain origin. But what if you do not know origin and you only know the position vector? So for example, you've been given point A and you know that it is a vector alpha with respect to some origin O, and there is beta with respect to some origin O. So then alpha vector and beta vector are called position vector. And now you have to do any operations. You say you need to find what AB vector is, right? So you don't know where the origin is. Origin could be this point, this point, this point, this point, right? You don't know origin, but you still have to find what AB vector is, right? So let's think, since we do not know the origin, let's think arbitrary that origin O is here. So then let's connect this point. This is OA vector, and let's connect this point. So this is OB vector. Now by triangle law of addition, OA vector, so we can say that AO vector, or sorry, BO vector So by triangle law of addition, we can say that AB vector is nothing but an OB vector minus OA vector, right? So AB vector is AO vector, or AO vector which is minus OA vector plus OB vector, and therefore AB vector is nothing but OB vector is beta vector minus alpha vector, which is a position vector of point B minus position vector of point A, right? So you can see, without knowing where O is or where the origin is, I could do an operation AB and find AB vector, which is nothing but a position vector of B, which is beta vector, minus position vector of A, which is alpha vector. Hence this concept is very important. In a lot of the questions, you do not have to know where the origin is, and you'll be able to solve questions. Now let's talk about another concept, which is section formula, right? So you have seen that there's an A vector, I have this B vector, so beta vector with, so A with position vector alpha vector and B with position beta vector. Then you have seen that AB vector is equals to beta vector minus alpha vector. Now let's think of a point P on this AB vector which divide AB in the ratio of m:1. Like this, AP by PB is equals to m by n. If you want to find a position vector of this point P, how would you find this out? So I claim that position vector of P is equal to n times P vector plus n times alpha vector upon m plus n. Let's prove this. So we can say that if we think of AB cat, which is a unit vector in direction of AB, we can say AB hat is AB vector upon AB. Now what is AB vector? It's beta vector minus alpha vector upon AB, which is nothing but AP plus P. Right? Similarly, AP hat is equals to AB hat, because they are in the same direction, is position vector of P minus alpha vector upon n. Right? This is beta vector minus alpha vector upon n plus n. Okay. So if we solve these two equations, sorry, we are going all space, so I'm going to use this part of the base. Let's use a different angle. We can say position vector of P minus alpha vector upon n is equals to beta vector minus alpha vector upon n plus n. Therefore, position vector of P is equals to n times beta vector plus n times alpha vector. I'll let you solve this equation. And this is what we call a section formula. So if there's a line, if there's a point which divides the line in section m and n, then the position vector of P is m times the position vector of the opposite point, and n times the position vector of this opposite point, which is alpha vector, upon m plus n. Hence, the section formula is position vector this, and beta vector plus n alpha vector. In the next videos, we would see application of section formula, and you will see why this is such a powerful formula to help you solve a lot of vector equations. See you on the other side of the video.